Hi there, everybody. So in this video, we are going to talk about graphing functions. All right. So let's go down to the overhead and get at it. Okay, here we go. So here is the first function I want to look at. This is a special kind of function called a linear function. We'll be looking at a lot of these, and that should give you linear functions. So that should give you a hint about what the graph should look like in the end. But we will go at that without even knowing what the graph's going to look like ahead of time. And so if we want to graph this function, one thing we can do is we can start by making a table of values. Okay, so what I'm going to do is I'm going to make a table with x on the left and f of x on the right. Okay, and now I'm going to pick some values for x and then see what happens when I plug it into the function, see what f of x is. So let's pick a mix of numbers. Let's pick some negative ones, like -2, -1, 0. We'll try 3. Okay, let's try these values. Now let's plug these into the function and see what we get. Now, to evaluate the function at -2, what I'm going to be doing is computing f of -2. And what that means to do is to plug the -2 in place of x. So that's going to be 2 times -2 minus 5. What's 2 times -2 minus 5? Well, that's -4 minus 5, that's -9. Okay, let's do the next one. This is f of -1. Well, that's 2 times -1 minus 5. When I simplify that, 2 times -1 is -2, minus 5 is -7. Let's try 0. F of 0 is 2 times 0 minus 5. Well, that's 0 minus 5, that's -5. What about 3? Well, that's f of 3 is 2 times 3 minus 5. Well, 2 times 3 is 6, minus 5 is 1. Okay, so we got a table of values here. So what we're going to do is we're going to graph, to graph the function, we're going to look at the set of points x, y, where y equals f of x. Okay, so this line represents our y-axis, and this line over here represents our x-axis. So a point xy, we go in the x direction the amount x, and in the y direction the amount y, and we find ourselves at a point xy. But in this case, y is going to equal f of x. So once we choose the x, the function is going to tell us where to go to find the y. And that's what we've already determined over here. When x is -2, we know the y is supposed to be -9. So what that's telling us is that if I go -2 units in the x direction, there I am, f of x is -9. So I'm going to count -1, 2, 3, 4, 5, 6, 7, 8, 9, and there I am. That's the point -2, -9. Okay? Now let's go to this one. This says that when x is -1, so when I'm 1 unit to the left of the center, f of x is -7. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and there I am. This one says that when x is 0, so that's right here in the middle, in the center, y is -5. All right, so 1, 2, 3, 4, 5. And this one says that when x is 3, 1, 2, 3, y is 1. So I'm actually going to go up 1 for this one. And what do we have here? We have, it looks like these points are lying in a straight line. And if you're not sure about that, compute some more values. For instance, I may not be convinced that it's actually a straight line. Maybe I think that it might be wiggling through these points. Let's try another number, f of 6, just to be sure. This would be, if I plug this into the function, it'd be 2 times 6 minus 5. That's 12 minus 5, that's 7. So let's just see where that goes. 1, 2, 3, 4, 5, 6. And I go up to 7. 1, 2, 3, 4, 5, 6, 7. Oh yeah, that's still in a straight line. So now I'm pretty darn sure that that is a straight line. If I were to continue plotting points, it looks like they would just continue falling on that line. So I'll just sketch that line. That line is the collection of all points that if I were to plug in every single possible number, I would end up filling in this line here. And so that is the graph of f of x. And as I said, it's a linear function, and so it makes sense that we get a line. Okay, so the steps. 1, make a table of values. 2, plot the points. And then 3, draw the line. Okay, so let's do it again. Here's our function. So I'm going to make a table of values here. I'm going to choose some numbers here. Let's try -6. We'll try -2. We'll try 0, and we'll try 1. Yeah, and I am thinking ahead about what things I might be getting out. So I'm trying to pick an array of things that'll give us some interesting answers here. But, you know, just plug in some numbers. If you start getting some crazy answers, try different numbers, okay? So let's see what -6 gives us. Plug -6 in for x. Well, that's going to be -6 plus 3 squared minus 4. All right, I'm just replacing the x with -6. Well, that's -6 plus 3 is -3. If you square it, you get 9. Minus 4 is 5. Okay? Plugging it in and evaluating the function. And it's very important to keep track of order of operations here. All right, remember order of operations. We always do what's in the parentheses first. I simplified this. Then I did exponents. Then I did the subtraction. So it's very important that you do those in the right order to get the right answers. I'd like you to fill in the rest of this table. All right, pause the video now, fill in the rest of the table, and then we'll check our answers together, okay? So I'll have you pause, I'll count to 3, and then we'll continue on. So go ahead and pause. 3, 2, 1. Okay, welcome back. You filled in this table. Let's check our work together. If I take -2, that's f of -2. So that's going to be -2 plus 3 squared minus 4. Okay, that's 1 squared minus 4. That's just 1 minus 4. That's -3. What if happens when I plug in 0? 0 plus 3 squared minus 4. Okay, well 0 plus 3 is just 3. 3 squared is 9. 9 minus 4 is 5. Okay, and finally 1. 1 plus 3 squared minus 4. 1 plus 3 is 4. 4 squared is 16. 16 minus 4 is 12. Okay, so let's go ahead and plot these points. We started with x is -6, so I count 1, 2, 3, 4, 5, 6 to the left because I'm negative. And then f of x is 5, so I go up 1, 2, 3, 4, 5, and there we have a point. Then we have -2, -3. So I count -1, -2, and the f of x is -3, so I go 1, 2, 3, and here I am. 0, 5. So x is 0, so I'm right here. And then y is 5. 1, 2, 3, 4, 5. Oh, this is interesting. Not getting a line this time, are we? X is 1, so I go here. And now y is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Uh-oh, I'm off the chart. Okay, so maybe we shouldn't use that point. Maybe we should try to pick a point that we can get on the graph. Okay, so it looks like by the time I get to 1, things are starting to get really big. So maybe going to 1 was a little bit too much. So let's pick some points that are more in this range to try to fill out where the graph, what the graph would be doing in here. All right, so maybe -1 would be a good thing to try. So let's try -1. F of -1 is -1 plus 3 squared minus 4. Okay, well, that's 2 squared minus 4. Well, oh, that's 0. Okay, so I can plot this, -1, 0. That's looking better. What about 1, 2, 3, -3? Let's try that one. So I'm doing f of -3 is -3 plus 3 squared minus 4. Well, -3 plus 3 is 0, right? And 0 minus 4 is negative 4. So that's the point. 1, 2, 3, 1, 2, 3, 4, negative 4 down there. And let's just do one more to be sure what's going on here. Let's do negative 4. F of negative 4. Negative 4 plus 3 squared minus 4. Well, negative 4 plus 3 is negative 1. I square it, I get positive 1. Subtract 4, negative 3. Okay, so when x was negative 4, 1, 2, 3, 4, y was negative 1, 2, 3. Ah. I think I have an idea of what's going on here with this graph now. Now I've plotted enough points, I can see it. It looks like it's coming down like this, and then it's curving around, and then it's coming back up. Right? Now the line, I should have gone through this point. I was a little sloppy there. Now the line just keeps going, right? So maybe it's good on these graphs to illustrate that. Sometimes you'll see people put arrows on these, right? To illustrate that they just keep going and going and going, right? But in this particular case, we get what's called a parabola. That's a parabola. Okay, and you can expect to get a parabola when you see a square in there. All right, let's do the next one. Here we have an interesting one with a square root. Let's see what happens here. So x. Now notice my function is not called f anymore. In this one, my function is called g. So that's what I'll be looking at, g of x. That doesn't make a difference. It's just a different name. It's like calling it Bob instead of George or Sue, right? It's just a different letter. We just decided on g this time. So let's look at different values here. Okay, we have a little friend helping us. Okay, fruit fly. Maybe he'll supply some answers here. So let's see here. I'm going to start with x equals negative 2. And I'm going to do x equals 1. I'm going to try x equals let's try 6. All right. Let's try x equals 7 here. And then I'm going to try x equals negative 4 just for fun here, and we'll see what these are. So what I'd like you to do is compute the values of g of x. All right, pause the video and compute these, but keep in mind we have a square root, and you should know that not everything is in the domain of the square root, right? So some of these may not have answers for g. Okay, so keep that in mind. Some of these you may not get an answer. Okay, so pause the video now, and we'll come back and check our work together. Okay, so 3, 2, 1. Okay, welcome back. Let's check our work. G of negative 2 is what we're starting with. Let's see what we get here. We have 2 minus the square root. I'm just copying this down with a negative 2 in place of x. Negative 2 plus 3. All right. Well, negative 2 plus 3 is 1. Square root of 1 is 1. 2 minus 1 is 1. Answer is 1. Okay. Notice how I worked from right to left this time. And that's just because I'm following order of operations, right? I'm doing what's under the radical first. The radical is like an exponent. Right? Do that before you do the subtraction. So that's why I started over here this time. All right, let's try 1. G of 1. Well, that's 2 minus the square root of 1 plus 3. Well, 1 plus 3 is 4. Square root of 4 is 2. 2 minus 2 is 0. Okay, great. G of 6. G of 6 is 2 minus the square root of 6 plus 3. Well, 6 plus 3 is 9. Square root of 9 is 3. 2 minus 3 is negative 1. Let's do 7. G of 7. 2 minus the square root of 7 plus 3. Well, 7 plus 3 is 10. Square root of 10 is, oh, what do we do here? Okay, in all of these, we got a nice integer answer. Now we're just square root of 10. Can we simplify that? the answer is no. There's no way to simplify square root of 10. Square root of 10 is as simple as that radical gets. So really, the only way I can write this is 2 minus root 10. Okay, but that's as simple as it gets. That's what I'm going to have to write here. Okay, let's go to the next one, g of negative 4. 2 minus the square root of negative 4 plus 3. Okay, negative 4 plus 3 is negative 1. Square root of negative 1 is, what's the square root of negative 1? It's when you take the square root of a negative, it's not a real number, right? So not a real number here, we're not getting an answer. In the online homework system, what you'll write is DNE, does not exist. Okay, so I warned you ahead of time, some of these may not have answers, and that's an example of one. Okay, these all above had answers. This one just isn't particularly nice, and isn't a particularly nice answer because it's not an integer, right? So it's not a rational number either, even. So it's even worse. It's going to be, we probably will have trouble graphing this one. So we're going to focus on these, all right? But let's look at this. Negative 2, when x is negative 2, y is 1. So there we are. When x is 1, y is 0. When x is 6, y is negative 1. 1, 2, 3, 4, 5, 6, negative 1. What's going on here? Well, I think we need to try some other numbers. It almost looks like a straight line, but I don't think it quite is. If you lined a ruler up here, it wouldn't be a straight line. So let's try some other numbers. Let's see, maybe negative 3 would be a good one to try. All right, g of negative 3 is 2 minus root negative 3 plus 3. Well, negative 3 plus 3 is 0. Square root of 0 is 0. That's fine. You can take the square root of 0. You get 0. 2 minus 0 is 2. Now, if you think about it, if I take any number less than negative 3, I'm going to run into trouble because that's when the denominator sorry, not the denominator, the thing under the radical, they call that the radicand sometimes if you want to be really geeky. The thing under the radical is 0. What was I saying? This is okay. The thing under the radical is 0. So if it's less than 0, then you get something undefined, right? But if it's equal to 0, you can take the square root of 0. It's fine. So anyway, 2 minus 0 is 2. And yeah, okay, so let's plot that point. 1, 2, 3, 1, 2. I think I lost my train of thought there and rambled a little bit. But okay, but what I was saying is that if we can't go less than negative 3, right? This is as far to the left as we can go, because as soon as this becomes negative, we can't take the square root. All right, so we're not going to have any points to the left of that. So I think we're good. I think we can kind of get an idea of what this looks like. Like I said, we can't go to the left of this point, because then what's under the radical will be negative. So I can only go to the right. So it looks like we're plotting out something that looks like this, and it's definitely a curve, not a straight line. Okay, I drew that not so great, but something like this. Okay. Really, by the way, what this actually is doing, it's actually 1/2 of a parabola. Remember how we had a parabola before? Well, this is 1/2 of a sideways parabola. But you don't graph this part. That's not what we were getting. I'm just pointing that out for illustrative purposes, to illustrate that this really is a curve, and what we're getting is the lower half of that parabolic curve. And that's what you can expect from square root functions. Okay? Let's go to this one. This is our last one. It is absolute value. All right? So our function is a. Why did I choose a? Well, either because my name is Andrew or it's got an absolute value, right? Maybe a bit of both. So let's try some different numbers here. Let me think here. Let's try negative 7, negative 4, negative 2, 0, 3. Okay. Let's even try 5. Okay. Oops, went off the screen there. Okay, so I'd like you to see if you can compute these. Okay? Actually, I'll start you off by doing the first one. All right? If you're adventurous, go ahead and pause the video and do them. Otherwise, I'm going to work one out for you. A of -7 is absolute value of -7 minus 2 minus 5. Notice I just put the -7 in place of x. Now, what's -7 minus 2? Well, that guy there, that's my attempt at curly braces. Okay, that's a -9. The absolute value of -9 is +9. +9 minus 5 is 4. Okay, so you do the rest. Pause the video. Okay, 3, 2, 1. Let's check our work. A of -4 is the absolute value of -4 minus 2 minus 5. -4 minus 2 is -6. Absolute value of -6 is +6. 6 minus 5 is 1. Let's do -2. -2 minus 2 is -4. -4. Absolute value of -4 is +4. 4 minus 5 is -1. Let's try a 0. This is -2. That's absolute value. That's 2 minus 5 is -3. Plug 3 in there. 3 minus 2 is 1. Absolute value of 1 is 1. 1 minus 5 is -4. Finally, the last one. 5 minus 2 is 3. Absolute value of 3 is 3. 3 minus 5 is -2. Okay, let's see what we're getting here. Go ahead and plot these points, and when we'll check it together. Okay, so pause the video. 3, 2, 1. Okay, let's check our work. I have -7 for x. 1, 2, 3, 4, 5, 6, 7, and 4 for y. 1, 2, 3, 4. -4 for x and 1 for y. 1, 2, 3, 4, 1. -2 for x and -1 for y. -2, -1. 0 for x, -3 for y. 1, 2, 3. 3 for x, -4 for y. 1, 2, 3. 1, 2, 3, 4. Ooh, what's going on here? 5 for x, -2 for y. 1, 2, 3, 4, 5, -2. Okay, what's happening here? It looks like maybe it's a curve like this, but then wait a minute. If it's a curve, look at how straight these are. If I ignore those, that's a straight line. That's not a curve. Let's get some more information on what's going on in here. Let's check the value of a at 1 and at 2. Let's just investigate that. What's a of 1? A of 1 is 1 minus 2, and absolute value minus 5. Ooh, let me get out of the way. Okay, this is 1 minus 5. That's -4. So 1, -4 is on the graph. And what about a of 2? 2 minus 2 is 0. 0 minus 5 is -5. So here we have 2, -5 is on the graph. 1, 2, 1, 2, 3, 4, 5. See what's going on here? We're getting a V. We're getting a V. Not a curve at all. And this is the kind of shape that you curve that you can expect from absolute values. Okay. One last thing I want to touch on. We're graphing functions. I want you to notice that in all of these, whenever we picked an x, we were able to get a distinct, a single number for f of x. We never had any ambiguity. It's not like we plugged in a -2 and got 2 numbers for f of x. That'll never happen. That'll never happen. So you always get 1 number for f of x. Okay? Now, what that means is that for every x, there's only one place you can go from there, either down, below or above the x-axis. You can't go to 2 different places. And what that means is that every function, the graph, passes what we call the vertical line test. So vertical line test. Every function passes the vertical line test. And what I'm talking about is that if we draw a function, no matter how crazy it looks, and I pick any point and draw a vertical line through that point, it will cross the graph only once. Any vertical line crosses the graph at most once. Now, it might be that the line doesn't cross the graph at all right? And we saw an example of that. If we look at our function over here, I can pick vertical lines over here that don't hit the graph at all. That's okay. But if I do pick any line over here, it's only going to hit the graph once. Remember, this dashed line is not part of the graph. Only hits it once. And what this also means is that some things, this is a way of identifying whether something is not a function. For instance, if somebody gave you a graph that looked like this, you know that this is not a function. Why? Because it doesn't pass the vertical line test. Over here we're fine, but over here we're not. If I take this point, this vertical line crosses the graph 1, 2, 3 times, more than once. And so therefore this is not a function. Not a function. It fails the vertical line test. Okay, so this is how you can identify if something's not a function. Look at the graph and see if a vertical line hits it more than once. Okay, so that's it for this video on graphing functions, and hope you learned something. I'll see you in the next one.